Hey there, and welcome back to the deep dive.
Great to be here.
This is where we take the source material you share and find the really interesting bits.
Just surprising stuff.
Exactly. And today, we're looking at something you might actually be working through right now. Math concepts.
Mm.
Specifically, integration.
And how it tops up in, well, unexpected places.
Right. We've got this piece of source material, just one source today, and it gives a really specific example.
It makes this claim, seems a bit odd at first, that integration is used for calculating energy consumption.
Yeah, energy consumption.
And the context our source gives, hydroponic farming systems.
Hydroponic farming. Seriously. I mean, okay, when I learned integration, I definitely wasn't thinking about like greenhouses or nutrient pumps.
Me neither. But that's what the source says. Integration helps figure out the energy needed for these pretty advanced farming setups.
Okay, so that's our mission for this quick deep dive then. Let's unpack this specific connection calculus and energy use in hydroponics based only on what this source is telling us.
Right. Just sticking to the source.
So the source flat out states, integration is used to calculate energy consumption in hydroponic farming, which, when you think energy bills, calculus doesn't immediately jump to mind, does it?
No, not really. You think about kilowatt hours, maybe checking the meter, simple numbers.
So why integration here? What's the source getting at?
Well, what's useful is thinking about what integration fundamentally is. It's about accumulation, right?
Hmm.
Finding a total amount when the rate of something is changing.
Okay, yeah, like finding the total distance you traveled if your speed keeps changing. That area under the curve thing.
Exactly that. So now think about a hydroponic farm. The energy it uses isn't just a flat line.
Right. Things turn on and off.
Exactly. Lights cycle, pumps run sometimes, not others. The heating or cooling adjusts. The rate of energy use is, constantly shifting all day long.
Ah, okay, I see. So you're not just measuring the power draw at like one moment in time.
No, because that wouldn't tell you the whole story.
You need the total energy used over a period while that power draw is going up and down.
Precisely. The source is saying that to get that actual total energy figure for, say, a whole day or maybe an entire crop cycle, you have to add up, integrate that changing rate of energy use over that whole time period.
Okay, that makes sense. Otherwise, you don't get a real picture of the system's true energy needs or costs.
Right. It's about understanding the cumulative total, the sum of all those little ups and downs in power use.
Just looking at a peak reading on a meter, yeah, that wouldn't capture the full picture for efficiency or cost when things are dynamic like that. This source really highlights how integration gives you that complete total.
It's a really neat example, actually. It shows how calculus isn't just abstract math problems. It becomes a practical tool for analyzing and maybe even optimizing real systems.
Even complex ones like modern farming.
Yeah, resource-intensive systems like that.
So thinking about you, the listener, maybe you're grappling with integration right now. What's the takeaway from this specific example in the source?
I think it means that these math tools you're learning, they are genuinely useful. They apply directly to understanding and managing pretty complex things, like how we use resources in, modern tech systems.
It's not just math for math's sake.
Definitely not. It's a key to figuring out how things actually work, sometimes in fields you wouldn't have guessed, like agriculture or energy efficiency here.
Yeah, this deep dive, just from this one source, really shows that link clearly. Integration isn't only for physics homework. It's helping people quantify something really concrete, like the energy footprint of high-tech farming.
And, if we just take that core idea from the source and think a step further, it does make you wonder, doesn't it?
How so?
Well, if integration is the way to calculate total energy use when the rate fluctuates in hydroponics, what other complex systems out there where resource use goes up and down, maybe in manufacturing or transportation, or even how data flows?
Yeah.
Could calculus integration be just as essential for analyzing and maybe improving those systems too?
That's a great question to leave things on. Lots to think about there. Thanks for exploring this unexpected connection with us today.